Hello. Should be live. And we started a minute early. Going to give a couple of minutes for people to tune in. But if you're already watching, say hello in the chat. I'll type there real quick as well. And then let me just get situated here real quick. How's everyone doing today? And if you want to say hello in the chat and also maybe put where you're watching from. If you have any other information you want to include, like what you're working on, that's always really fun to hear about too. And then also we can kind of maybe tailor sometimes, what we talk about if you have a specific project going on. David said, happy Tuesday, everyone. Happy Tuesday. Thank you, David. How's it going? Are you working on anything fun or interesting? I guess it doesn't have to be necessarily fun. Hopefully it is, though. And I'm just going to bring up the other live stream real quick. So if I need to post a link, I can. All right. Well, we're waiting for people to roll in. Anyone who's already here. Also, if you want to let me know, you can see the screen, hear me just fine. Let me know in the chat as well. That's always good for me to kind of double confirm that. All right. So if you want to follow along today, which I hope a lot of the people do, the only thing you'll really need to probably do is sign up for this account. It's free. There's no card required or anything like that. And you might want to sign up right now because it can take like 3 to 5 minutes to process your sign up. All the links for everything are also, by the way, in the description. So if you want to go ahead and pull up the code, you can. I'm going to go through a few slides before I walk through all the code. But I know when I'm attending workshops, I like to jump around a little bit and maybe get a head start. So if you want, you can also check out the code already. I'll share a link in the chat as well. But again, these are also in the description. So also if you're watching the recording, you can go look in the description, find them there. That is a GitHub link. And then you'll just want to hit that open and collab link right now. There's some other code in there as well, and I'll be adding to the README later. But for now, you can follow along with the code. And then also, if you want to stay connected and ask questions later, which I encourage you to ask questions during the workshop, I'll do my best to answer them. If I don't get to them, or if you're following along later and have questions, join the Slack channel as well. And I hang out in there a lot. And we also have other cool stuff going on in there, like an AI book club. And there's a whole bunch of members. I think it's like 3,600 people in there now. It's a pretty fun, active ML community and MLOps practitioners. So again, while we're waiting for people to join in here, I'll probably wait another minute or so before I start really rolling in the slides. We're going to go ahead and build this today. So I'm going to go through some slides first, and then we're going to do a lot of hands-on stuff. So I hope people are ready for the hands-on. It should be fun. But we're going to build a machine learning pipeline that is going to download a data set. It's going to process that data. We'll even store kind of visualizations of what this looks like. This is a pair plot of the iris data set in this case. And then we're going to train a machine learning model. We're going to evaluate that model. Again, get some performance metrics and charts. And then we're going to save a version of our model to Hugging Face Hub. And we're also going to have another little prediction layer so we can play around with our model here. And then we'll also go into the notebook where we can download that model from Hugging Face Hub, download the versions, and then interact with it locally as well. So we're going to build kind of a whole little ML pipeline that starts with getting the data, processing it, training, evaluating it, and then saving versions to it. And that's a pretty common workflow that you're probably going to encounter. So again, if I see a whole bunch of people joined, so if you haven't already, you should definitely say hello in the chat, maybe include where you're watching from, and then also put a little bit about maybe what you're working on, why you're interested in ML pipelines. That'd be really cool to hear. And then also maybe if you want to put a little extra information, like have you done machine learning before? Have you trained a model? Kind of what model or what machine learning have you done? Let me know in the chat. It's kind of fun to hear about where the audience is from and what you're working on, and then I can kind of maybe tailor some of the stuff I talk about a little bit about to your projects if you let me know what they are. All right, so saw a whole bunch of people come in. Let's go ahead and get started. Again, I'm just going to be going through some slides, and then we'll go and do the hands-on part. And again, for the people who just joined, the thing you want to do right now, if you do want to follow along, is just sign up for this Union account. I'll talk more about what this is, but it's the platform that we're going to be using a Python SDK to kind of build our pipeline today. I'll talk more about this, what it is later. It's also built on an open source project called Flyte. So you can do what we're going to do today in open source, but we're going to be using the serverless version of Union because it's really easy to set up during the workshop. You don't have to set up your own Kubernetes cluster or anything like that. And it's going to make it really easy for you to run all the stuff today. But just know what we do go over today, you can also implement in open source. All right. So I shared that link again. Sign up. That's the only one. You can sign up for a Hugging Face account later too. I'll talk more about that when we get to it. That should be pretty quick. And that doesn't stop you from the whole pipeline. It's just the last part of it. So I'm going to go ahead and get in the slides. We'll do some slides. I'm going to go through them quickly, and then we'll go into the code. But again, links to everything is in the description. So if you want to go ahead, pull up the code and stuff, you're more than welcome to. So this is an intro to ML pipelines. Hopefully this will be really fun if people haven't trained or, well, if you haven't trained a model, it should be fun too. But if you haven't built a ML pipeline before, maybe you've trained a model in a Jupyter notebook or some other space, and you haven't really put everything together in like a reproducible pipeline before, this should be kind of a fun workshop for it. And someone said they're also streaming from Seattle. I forget if I mentioned earlier, but that's where I am, and that's where I'm streaming from. They said they're new to machine learning and looking for projects to sink their teeth into. Awesome. Well, this will be, I think, really fun, kind of to learn about how to build like a reliable and efficient ML pipeline for machine learning projects. A little bit about me. My name is Sage Elliott. I work at Union. I live in Seattle. I run an AI book club. If you follow me on LinkedIn, you might see some posts about it. We were meeting weekly. Right now we did the last couple months, once a month, but we're going to be meeting weekly again, and we read a new book every month. So if you like learning about AI, it's a really fun book club to join. Previously, I've worked a lot in computer vision for a few years at a company, and we did a lot of interesting deployments on like edge devices as well, and building pipelines in different ways for that. And then I've also worked a lot with ML monitoring and evaluation, which is an important part of most pipelines in production. I'm always happy to talk about that kind of stuff. We're not going to dive deep into that today, but I will be building future examples with the ML monitoring and really tying this kind of ML lifecycle together, which will be really exciting. And I've also worked in hardware and IoT and MLOps before. And if you want to stay connected, you can connect with me on LinkedIn. Pretty active on there. Feel free to message me, or you can post in the Slack channel. Whoops, to just copy this link. Join the Slack. It's the official Flyte Slack, which is the open source tool I mentioned earlier. And there's a whole bunch of channels in there. And there's an introduction one. So if you want to put a more permanent introduction, you can do that there as well. And then again, a little bit about you. If you just tuned in or you haven't said anything yet in the chat, put where you're watching from, what are you working on, why you're interested in ML pipelines. It's always fun for me to see as I'm doing the workshop, but also other people here. I think it's kind of fun to stay connected with other people going through the same workshop. So quick overview again of what we're going to do today is we're going to build a reproducible pipeline, and we'll talk about some of the features that kind of make it a reproducible, reliable, and efficient pipeline. But with that, we're going to create a container image that we're going to run our workflows in. We're going to have a task, which is a task is like a segment of a workflow. A workflow is all these tasks together. We're going to download a data set. We're going to process the data and visualize it, do kind of some like exploratory data analysis in there, as well as doing our train test split. Then we're going to train a machine learning model. We're going to evaluate that machine learning model, and then we're also going to save that model to Hugging Face Hub in this case. And I just want to mention that the pipeline might be relatively simple depending on like what you're working on, and if you've been doing more complex machine learning workflows or machine learning models before. We're going to be using scikit-learn today, but all the concepts that we go over today can extend to more complex models and pipelines. So again, it's like relatively simple, so we can quickly run it during this workshop. But if you're using more complex models and you have way more steps, this can easily scale to that. Right, so MLOps and LMOps and ML pipelines. You might have heard the term MLOps before. It's usually kind of a set of practices and tools that aim to deploy, or it should be, in my opinion, like deploy, monitor, and maintain machine learning models in production reliably and efficiently. So you've probably seen, a graph like this potentially, and this is a similar to what I showed earlier of what we're actually going to build today. But this is kind of some of the common steps for most machine learning pipelines, and they definitely extend like way more complex than this. But at a bare minimum, you're probably going to have these types of steps together. where you're collecting data in some way, you're training a model on that data, you're evaluating that model, you're going to ship that model if it's good enough or better than the previous model. Then once that model's in production, you often want to monitor it in different ways to make sure it's still performing as expected, or maybe improving. And then you typically kind of want to build this into a loop. So you're continuing to often collect data in production, using that new data, especially maybe if it's variations that your model wasn't trained on before. And then you're going to train a new model with the data and kind of start this whole little loop over again. Again, this is a kind of a stripped back pipeline. It gets more complex with, you might have more tracking for experiments. You might have vector databases and guardrails for LLMs. You might have shadow deployments or A/B testing deployments. But kind of at a bare minimum, you're probably going to have something like this. Has anyone built a pipeline kind of like this before? Or maybe it's just been a local thing. But yeah, I'd love to hear about people's kind of background and like what they've worked in so far. And you might have seen this is just such a small subset of all the tools out there, but for all those steps and more, there's so many tools that I feel like so many like cool tools come out almost every day right now with all this awesome um, focus on LLMs and AI right now. There's so many interesting startups and tools being created all the time. Has anyone used any of these tools before? And so here's some of the common ones for some of those steps we talked about. I'm not going to read off all these tools. There's a lot in here, but we have often like extract, transform. That's kind of on the data collection side and pre-processing side. You might validate that data. You might explore that data. Again, we're going to do a little bit of that today as well. You're going to train a model, test that model, deploy, monitor, and then kind of retrain and build that loop like we talked about. So there's so many tools. We're going to be using a few of these today. But if anyone has experience with any of these specifically, let me know. There's a lot of really cool ones in here. Bento ML is doing some really cool stuff with deployment. And then at the core of kind of this pipeline, you have something called orchestration, or often I'll use the term AI orchestration or ML orchestration for ML pipelines. But really, you can orchestrate any other types of jobs, including like data engineering workflows. And this really helps create a reliable and efficient pipeline with workflows in your AI application. So you have things like scalability. It's going to facilitate scaling of AI workflows to handle those really large data sets and complex models. Reproducibility, you want to ensure that workflows could be consistently reproduced. So you might have heard of like Docker before and using containers, right? Because otherwise you might just be working on different environments. You want to make sure it's going to work the same over and over again. And then versioning is a big one. So if you've trained a machine learning model before and you're changing code, you're changing data, you have new models that come out of it. You want to be able to kind of track all those changes over time and basically have a snapshot of every time you do something like that. So you can, roll back or see exactly what happened that caused the thing. And depending on the industry you work on, this could be basically required. Improved efficiency is a big one, where you allow data scientists or ML engineers to really focus on like writing great code, often in Python right now. You're kind of worrying a little bit less about the infrastructure and shipping code, which again, we're going to see this in action, what that looks like today with the Python SDK. And then cost efficiency. If you build out a pipeline correctly, you can really optimize your resource usage, both in terms of like compute resources, but also your engineering resources, which reduces the overall cost of developing AI models, and also like where your engineering team is spending time. And so just a couple more points I'm going to hit on for when you're choosing like a good orchestration type tool or building ML pipeline is you also might want to look at optimizing for local and cloud development. So this is something that's interesting, where not every orchestration tool or pipeline tool you can develop locally. Like you might have to do it in the cloud somewhere. So you want to utilize local computing resources over the expensive cloud for testing iteration. So with Flyte, again, like the open source ML orchestration tool that we're going to use today, you can write your Python code locally in tasks and workflows and then run it if you have the compute resources for it. Sometimes if you're training something like a really large language model, you might have to even test that part in the cloud. But a lot of times people have very powerful hardware today where you can run ML models, or maybe you even want to run your pipeline with a smaller ML model first and then kick off like a large training job with a bigger one in the cloud. This saves a lot of time on troubleshooting because you don't have to wait for like the cloud to kick off and run there. You can actually just run it locally. Leverage caching in the pipeline. Caching capabilities can speed up the development cycle by avoiding redundant computation. So for example, let's say here I'm downloading a data set and I'm pre-processing that data set. And I don't care about doing these each time I run the pipeline. I know that, my data set didn't change in this case, and I'm good with the pre-processing that's done. So I want to cache those models, and I can rerun this whole workflow because maybe I'm changing hyperparameters and testing different models out. It's not going to rerun these tasks each time. I can just kick off the whole workflow, and it will run all the tasks that aren't cached. Again, if you have like a massive data set, this can be really time consuming. So if it's just already cached there, that can save a lot of time. Task level resource management and containerization. So we talked about containerization briefly before, but precisely, managing the resources for each of those tasks inside a container can also really reduce your, computation resources used. So for example, let's say back over here, we have this get data set, and then we have this train model and this pre-processed data set. Maybe on this get data set, pre-processed data set, I just need pretty lightweight CPU computations, but I don't need a GPU. But when I train a model, maybe I do need a GPU. And instead of running all of these on a GPU instance, I can run just each task on the compute that I defined. So the GPU could run only on the train one in this example. For the get data set, it's just using a CPU and some low memory. And then when I want to train a model, then that's when I request a GPU. And it's not running the whole time. Other people can use that GPU, or I don't have to potentially pay for it when I'm not using it. So that can be a big cost saver as well. Type safety. So Flyte also has built-in typing that you have to use when you define each task. So you're going to say, the input's a string, the output's an integer in this case. And if I mess up in my code somewhere, or I reuse a task in a different workflow, so you can define tasks for one workflow and then use them somewhere else, it's going to basically force me to adhere how I written that task, and it can reduce a lot of debugging time, and basically just adds a layer of safety to your tasks when you create them, so you kind of know what's coming in, what's coming out. And then we won't be using this today, but also if you're, building your own cluster or using your own compute, like with Flyte or with the Union Bring Your Own Compute version, you can utilize spot instances from different cloud providers. They often are quite a bit cheaper than potentially paying like full cost, and so that can also be a huge way to save costs. Also, slightly different than maybe exactly the spot instances, but not everything needs to be run in real time, like a real-time chatbot. So if you're processing a whole bunch of documents, you want to run a batch job, you can even use something like OpenAI's batch pipeline cost, which is, I think in this case, it says it's like 50% cheaper than using their live API. So if you're okay waiting an hour or two for you to process all these documents because it's not a real-time use case, you can check out using things like batch instances or spot instances, and that can save you a lot of money too in your pipeline. So today, I'm going to quickly go over the tools we're going to be using, and then we'll get into the code here. So we're going to be using Union, specifically Union serverless, which I will mention the serverless part is in beta. Union's built on top of open source platform called Flyte. You can check it out here on GitHub, Flyte, which Flyte was the AI orchestration tool built internally at Lyft. That's why it's spelled that way. And then it became an open source project under the Linux Foundation. And then Union is a platform built on top of it. So when we have really cool features that come in from the community, the awesome Flyte community, those also get contributed to Union, and we're still one of the core maintainers of the project as well. And I'd mentioned like there's serverless. There's also the Union Bring Your Own Compute, which is like a managed version of Flyte that makes it really easy for your team to get set up with this reproducible infrastructure. But again, serverless today, we're going to sign up, use it. If you do see any bugs, please let us know. If you break something or you find something broken, let us know so we can fix it. Just mentioning that it's in beta. So if something does happen like that, let us know and we can make sure we fix that bug. So again, we're going to see what this looks like in the code here shortly, but we're going to define several of those tasks like we had mentioned, like get data set, train model, etc. Each of those are a task that has an input and an output. Each one of those is containerized, like I talked about. Each one is also versioned. So the artifacts that are generated, the inputs, the outputs of those tasks get kind of saved in a snapshot. And they're strongly typed, like I'd mentioned as well. And basically, when we're using the orchestration tool that we're using today, You have the declarative infrastructure. So again, we'll see this in action, but we're going to be able to write like exactly what compute we want for each task, just like we had kind of shown in one of those graphics before. You have versioning. I keep mentioning versioning. It's really important though, and I think just a really cool feature that's just there without you really having to think about it. I don't know if you've tried to build versioning into some other pipelines before. So it's just nice that it's just like there. We have the caching feature like we had talked about, type safety. It's incredibly flexible, so you can integrate with almost any machine learning library that you might be using in your project. You have checkpointing, so if a task is failing, you want to come back to it and rerun from where it failed, you can. And then it's scalable. It's built on Kubernetes. And for the machine learning today, we're going to be using scikit-learn. Like I mentioned, this might be a relatively simple pipeline, but it all scales or it can all scale to your more complex pipelines that you might be building. If you're new to machine learning, basically we're passing data into a function, and it's going to be learning patterns from that data, and then we can pass in a new piece of data, and they get a prediction. In this case, we're going to build a little classification algorithm, and how k nearest neighbors work, which is the algorithm we're going to be using today from scikit-learn, is basically gets this new piece of data. It's going to be looking at the k number of closest neighbors. We get to define whatever that hyperparameter it is. And then in this case, it says 3 are versicolor, 1 is virginica. It's going to guess that this new piece of data probably belongs to that versicolor, just from what we're seeing here. Saving and versioning models. So again, a lot of that's already built into Union of Flyte. But we're also going to have an end step where we save it to a Hugging Face hub. So it's pretty common in your workflow where you might want to move a model to a hub or some sort of space for deployment or versioning as well. So we're going to be using Hugging Face for our hub step here. And with that, let's go ahead and get into the code. I will also pause kind of as people are getting set up here. Any questions people have so far, let me know in the chat. I see a lot of people here, and I see some people talked in the chat. I'm going to catch up to those as well. First, I'll say you can go to this GitHub repo. Again, everything is in the description as well. Or if you're watching on, you scroll down and you should see them in the description. And then if you haven't already, sign up again for free. There's no card or anything required to the Union serverless. That's what we're going to use today. Again, that can take 3 to 5 minutes maybe to process once you hit register. So do that now, and then you'll be ready to roll. Somebody asked, what approaches do you recommend to determine if your data has changed? So there's a lot of really cool tools right now. You can use some of the open source ones. You can also use their platforms. I used to work at a company called YLabs, and they have an open source tool called YLogs. You can look at that. But at a bare minimum, if you don't know exactly what to measure in your ML model, I would look at the data coming into the model and the predictions coming out of your model. And then you can kind of compare that for something called data drift. So you could, at a bare minimum, compare new data to your training data set, let's say, and then you can actually see like how much it's changed versus your training data. But depending on the type of model you're doing, you might want to look at kind of a rolling window. So you could look at like the last 5 days of data and then see how much the data has changed over that time as well. But I would look at YLabs or look at Arise. That's another cool one as well. Also depends on what type of model. So if you're using tabular data, that's different than like a large language model, right? So I shared this link. You can open it up in Colab here. So we're going to run everything in Google Colab today to make it incredibly easy. I'll share the direct Colab link as well. Once you're in Colab, you can run it all here. I personally usually like to save a personal copy of something like this. So I'm going to hit save a copy and drive. That's going to allow me to actually edit code, come back to it, and it won't be changed. So if you edit stuff in here, you can edit and run it. But if you reload the page, then it's going to go back to the default state. So I kind of like to save a copy and drive. And then you can hit this run on this first code cell. Or you can, when it's highlighted, hit Shift Enter. Often I hit Shift Enter. So if you don't see me pressing that play button, it's because I'm hitting Shift Enter. And this is Google Colab. It's Google's way of hosting a Jupyter Notebook. Many of you might have used one before. It's okay if you haven't, but it's a cool way to host kind of code and documentation like text and images kind of all in one place. And it's really great for like experimentation, running workshops. I love using it for running workshops because you can follow along all these code snippets and just kind of change stuff as needed. And yeah, has anyone used Google Colab before? we don't need it today, but it also gives you free GPU time, which is pretty cool. So if you're looking for a way to get started in deep learning or computer vision or something where you need a GPU, and you don't have one, you can use Google Colab to get some time as well. So did anyone open up the notebook? Oh, and also let me know for people who wanted to follow along, and if you hit sign up for Union, were you able to sign up? Did you get like a confirmation email? Oops. Someone said yes, they got it. Awesome. I'll share it one more time. So again, if you want to follow along here, hit that sign up link, and it should be really quick for you to actually sign up, and then it takes a couple minutes for it to process. So someone said yes. Okay, cool. Another person said yes. I'm going to catch up a little bit on some other questions real quick while people are setting this up. So again, let me know in the chat. You open up this notebook. You probably saved a copy if you want to have your own copy. And then you hit sign up. Also, if you're looking for something else to do while we're waiting here a minute, if you don't have a Hugging Face account, you can also hit sign up on there. We're going to use it for the last part of our pipeline. So if you don't want to make another account, it's okay. You'll run most of the pipeline. You just won't be able to save a model to it. So Hugging Face, in this case, we're going to be using something called Hugging Face Hub. And it provides a place kind of like GitHub, but for models and data. So I can go look at my repo here, my repos, and I have this repo that contains a model. This is what we're going to do today. And then I can update this model and download that model. And if you need to create a token or create an account, we'll go over the token again when we need it. But if you want to look at it right now, you can go to settings, go to access tokens. You can create a new token. And then when you create a token, you can just hit this read access and write access. So it can create a model and then pull it down. But again, you don't have to worry about it right now. We'll come back to this when we need it. But I do just want to mention that you can go ahead and create the Hugging Face account if you want right now as well. All right, so some people said yes. Anyone else? Did it work? Did it not work? Everyone has their own copy. Everyone signed up for Union and is at least waiting, I'm hoping right now, to get a confirmation email. I'm going to keep going on the code. If anyone has any issues, though, let me know. All right, let me go back to my copy here. And so I hit this run, printed hello world. Once you sign up for Union, you should be able to go to dashboard. Yours is going to look pretty empty, probably. Mine has a lot of stuff going on in it right now. And I can see in the past 24 hours, these are all the ML workflows I built. And again, we'll come back to this and explore it more in depth later. I can look at this run, though, that I did. This is that pipeline I said that we're going to build. Here's that graph pipeline. You can see they all succeeded. All right, so let's actually go ahead and run our first workflow. First, I should have told you to do this a little bit ago too. Go ahead and run this code cell that's going to install the necessary libraries for our project into Google Colab. So this should just take a minute. I don't know, for you, usually it would tell me what's installing. I'm not sure if we have too much going on here in this code cell or something. So it is working. Just give it a minute or two, and it's going to install all these packages. It's a good thing to do maybe while you're waiting for that Union sign up to go through. Let me see if there's any other questions I missed real quick. And again, if you have questions, put them in the chat. I'm going to try to get to them. If I do miss them, I'm not trying to purposely miss them, but I know sometimes there's a lot going on in there. And then I also want to keep the workshop going. So feel free to ask them again if I didn't get to it. Someone said they were watching from India. They've been in machine learning since 6 months and currently competing. Ooh, it sounds like a cool, I don't know what the ARC AGI prize is, but that sounds cool. Is that a competition on something like a Kaggle or a different site? Someone said pip or pip3. For this case, it's fine just to run pip. Pip3 is often in, like, if you have different versions of Python installed. In this case, just run the pip command in your Jupyter Notebook environment here, or Colab environment. It has its own little Ubuntu instance set up, and it'll install it in the correct place. So you can see mine's installed. Awesome. And then one thing we need to do before we run our first workflow is to authenticate basically our instance here to union. So the notebook, you can just run this union create login auth device workflow. It's going to generate a link down below. You just want to click on this, and then it's going to already have this authentication code in there, and then hit next. Go back to your notebook once it says, device activated here, and then you'll see login successful. Also, sorry, I'm going to zoom in. Hopefully that's better for you to see if it was a little hard before. Right. And then again, someone in the chat, let me know if that worked for you. Because it's important, have authorized before we move forward. We're going to build our first really simple workflow, and then we're going to build that more complex one that we saw earlier. And also, so since we're using Colab or Jupyter Notebook, again, kind of to run our stuff in today, you'll see this up top on some of these files. It says write file. And then in this case, it says simple WF, which is for workflow, .py. What this is going to do is when we run this code cell, it's going to take the code here and create a Python file containing that code. That's so we create a .py file, a Python file, and then we can run a workflow from that Python file with Flyte or a union. And so it's not a union or a Flyte specific thing. This is just like a Jupyter Notebook kind of workshop thing that we're doing that makes it easier for you to follow along. But you'd actually develop your Python files locally probably, and then kind of run the workflows from there. All right, so I'm going to go ahead and run this first one. But again, someone in the chat, if they can let me know that it worked. Okay, cool. People said it worked. I think I had a little bit of lag. Says worked. Awesome. So you're authorized. I hit this. I ran this first code cell here, and this contains our first simple workflow. Again, we're going to make a machine learning specific one, a little bit more complex here next. But we can see a couple things. So we have two functions defined here. One is just hello world. You've probably seen something like this before. It's taking in a name that has to be a string. Remember, each task here is strongly typed. And then it's going to produce a string. So it's going to return a string. So we're going to take in a string and then return hello name, right? Or world, whatever word you want to put in there. Then we have a workflow, and then the top part of this is at task. That's the decorator telling us that this is going to be a task in our pipeline in Flyte or Union. And then we have a workflow, which, again, we'll see a more complex one later. But a workflow is how you kind of define the tasks and how they run and how data flows through them. So this workflow is incredibly simple. It's just going to return one task, which is going to be hello, and then a variable that we're going to pass through. So again, like we mentioned, we can run these workflows locally, which is really cool. We're going to do that here. We're going to say union run simple workflow.py and main. We can see the main is the name of the workflow. So we're going to run that. And then we're going to pass in a variable. Here I'm going to say Flyte. And so it's going to run locally here. And it says hello Flyte. You could change this again to any text variable you want. It's going to say hello workshop now. And awesome. So now let's run this remotely, where we want to run it on our compute infrastructure. So here I'm going to hit run, and I'm just going to add this remote tag on. Same thing, simple workflow.py, main, and then I'm going to pass in a variable. So I'm going to hit run. And if you authenticate it to union, it's going to run execution on remote. And then you're going to get this little URL. And click on this, and it should open up a union window that looks like this. Again, let me know if it worked in the chat. Always great to have confirmation that things are working and people are following along. So we can see this list of nodes. In this case, we only have one because it's an incredibly simple workflow. Again, we'll be building a more complex one later. But it says hello world. And then we can also look at it in a graph view. I kind of like this view a lot, where you get the DAG of the actual flow of your data and what it looks like. And then we also have a timeline, so you can see how long each task took to run. So let's go ahead, and I'll just be in this graph view real quick. I can also see there's a version tied to this. So if we run this again, we're going to get a new version. There's some other data that you can look at as well. I'm going to go ahead and click on this node in the graph section. But again, you could be in node section and click on it here as well. It brings up this little side pane that tells us everything about our tasks. So when we have a whole bunch of tasks, we can go through and see all sorts of data logged here, which is really cool. So executions just tells us how long. Again, there could be more data here when you're running more complex tasks. Let's look at inputs. We can see that the input contains that string that we passed through when we ran it. And the output here is hello Flyte. That's what we were expecting. And then there's a lot more kind of task level stuff here. But what's really cool is, we could rerun this workflow from our command line like we did before and pass in a new variable. But now that it's already registered here, we can actually just rerun the task or the whole workflow. Let's actually rerun the whole workflow. So I'm going to exit out of this little task pane, and I'm going to hit relaunch on the workflow here. And now it gives me a place where I can put in that variable. So again, I can say, hey, workshop from here, and then I can hit launch, and now it's going to rerun that task with that new variable. And again, this is a really simple workflow. We're going to be building the more complex one here in a second, but you can already see how this is probably really cool. You have a version of each one of these. Now we can actually see when I relaunch this task too, or workflow, it even says which one it's related to. So this is the original one I can click back and look on. This is the new version. And then I can, again, open up the inputs, outputs, and we can see now it says hello workshop. So this is really cool if you want to rerun workflows and change things like hyperparameter optimization, which again, we can see actually here when we run our ML workflow, or any other type of inputs that you want to go to your pipeline. You can do it directly from the UI, which is pretty cool. And cool. So someone said it worked. A couple of people said it worked. Great. Anyone else? This worked. You're following along. It's working great. What do you think so far? Again, we haven't done anything too crazy yet, but does this seem maybe interesting? How we're defining these tasks and workflows. Also, so you can always run, like this happens sometimes. I'll write a really complex workflow and then I forget exactly all the stuff I need to pass into it. You can say union run. This is our workflow name, main again, and then help. And I'll say, this name parameter is required to run. And we can also say union run help. We're not going to go through all these, but there's a whole bunch of different stuff. Again, you can look at the Flyte documentation or union documentation and see kind of all these different things you can do. So actually, one thing I'll show real quick too before we get into the ML pipeline is if I hit this button up here, it's going to take me to this place where there's default and systems. You can define new projects as well here. But by default, you have these two. System shows container image builds, which we're going to do here in a second. And then you have default, which is all of our other tasks go in there by default, but you could create different ones for different projects as well. And then I can click back into my most recent execution and then kind of dive in again to everything that we just saw. So let's go build our more complex ML workflow here. Again, we're going to create a container image. So when we just ran that last task, didn't really need any specific libraries. It just needed Python. So we didn't actually have to tell what was in that image. Then we're going to download a data set. We're going to process and visualize that data set. And then we're going to train the machine learning model, evaluate machine learning model, and then save that model to Hugging Face Hub. And then we're actually going to do one more task too, which is then we'll predict on new data. So once we have an evaluated model, sometimes I like to have another task where I can pass in something that I know maybe is like out of the realm of the data set and see how that model behaves. But you could also have that as a separate workflow. In this case, we have a really lightweight model, so it's not a problem for us to have it just as part of our default workflow. First, though, if you created a Hugging Face account, we want to put in that token. Again, if you skip this part, you'll be able to run most of the pipeline. It will just fail on that last task. So once that authentication pending and device activated. Cool. So I think that means you hopefully are activated now. All right. So first, if you haven't already, and someone says, but they still are getting the authentication pending. Try stopping it. Hit the little stop button on the authentication one, and then try rerunning it again and see if that works for you. If not, let me know in the chat. And if we don't get to the second, I'll definitely look into it later or have engineering look into it. I'm right. If you didn't already and you want to do that last step again, it's okay if you don't. Go to Hugging Face. And again, I'll go show you how I created my token. I'm just going to go to settings. Again, Hugging Face is free to sign up for as well. And then I'm going to go to access tokens. And then I'm going to create a new token. So you could call this whatever you want. I'll just say workshop. And then you want to have this read and write access to your Hugging Face repos so that we can upload a model. And then also later, we can use that same token. We can download a model. But you can create fine grain ones for all of your pipeline. Someone said they were put on the wait list when they signed up. It should be approved in a couple minutes. So if you don't have it right now, look out for an email. It might take up to like 3 or 5 minutes, I think. And then you should be approved for it right now for the workshop. Once you do that, hit create token. This workshop will also be recorded at the same link, by the way. So if for whatever reason you can't follow along right now, but want to come back to it, you can save or bookmark this link and come back. And all those resources, again, are in the description as well if you need to revisit anything. Hit create token. Now you're going to have your token here. And then we want to run this union create secret. So we're going to be managing our secrets here in Union today. So now it's kind of hard to see, but this is actually a text box here in Colab. And then you paste in your token and then just hit enter. And then you should have a new token saved in your secrets here. And then I already have a Hugging Face token saved. So I'm actually going to stop this and just run this next code cell, which is union get secret. And this is going to show me a list of all the secrets I have. I have a few more. I have like a Hugging Face one, OpenAI, etc. Weights and biases. Those can all be saved in Union, and then I can pull them in when needed. And you can also easily delete your token just by running union delete secret and then that token name. It'll delete it. And then I'm going to walk through all this code, but what I do recommend, just so you can run it more in a timely manner, because you're going to have to build a container image real quick, is I would hit run on this code cell, which is this big one with all this code. Again, I'm going to come back to this here in a second. Hit run. We are writing to this workflow.py. By the way, if you want to, you can always look at this little folder icon, and we can see our .py files that exist now in Colab. And then we're going to hit, but this is the help function again, letting us know what variables we need to pass in. And then we can hit union run. If you run this right now with this default thing, it should still build the image. But what you want to do to run it is actually put in your Hugging Face username. So mine is Sage Codes, and then whatever repo you want to upload the model to. You can make up a new name if you don't have an existing repo. So I'm just going to put ML repo, and I'll create this if it doesn't already exist. And then we're going to pass in model pickle, and then go ahead and run this. And again, if you didn't update the repo name thing, that's okay. This is just going to kick off the build. And since it's your first time running it, it's actually going to build an image, which shouldn't take too long. It should probably just take a couple of minutes, but this way you won't have to wait for it when we actually get to this part later. But you can see I already have an image built containing those libraries. So it skipped the building, and then it's just going to go ahead and run that task. So I'm going to go ahead and run up to this code now and walk through what's going on here. I'm going to go kind of high level at first. And let me know like if there's anything you want me to come back to, but I'm going to go maybe kind of high level, try to go through this quickly. We can run the workflow, and then if we want to, we can come look at any specific code piece that you want. But I want to make sure that we kind of end here on time, but I'm happy to hang out longer and answer questions as well. So we're going to import a whole bunch of modules, scikit-learn, some other visualization tools that we're going to be using, HTML, because when we build something called a Flyte deck, which if you're here at the beginning, you saw those visualizations saved in those tasks. That can be kind of any HTML element. And then here, we're going to define the container image to build for the tasks on Union with something called image spec. We can pass in all the requirements, kind of like a requirements.txt file. We're saying, we want scikit-learn, matplotlib, this specific version of Union, Seaborn, joblib, Hugging Face hub, pyarrow, and python.env. And also, so this code, you can run it locally with a .env file. For the workshop, we won't actually do that, but this is made so you could take this and run it locally as well if you save like your Hugging Face token as a local secret too. There's a little convert fig to HTML function. This is to convert figures to HTML, so they can be embedded in the Flyte deck. Here's our first task, which is going to be download data set. Which is going to download the data, obviously. And we have a few things that we're going to set in here first. So before we saw just this task, This is kind of where that declarative infrastructure piece comes in, where we can easily define how we want the task to behave and what resources it should use. So in this case, I'm saying cache is equal to true. If you were here at the beginning, you remember that slide probably that showed that, we can enable caching. So if I rerun this whole workflow every time, it's not going to download the data set every time, because it could be a pretty long process if you have a really big data set. You have a cache version. So if you do want to overwrite a different version of the data set, you could change this and it'll save it to a different version of the cache. Then we're going to say we want it to run on this image that we defined above. Again, you could have multiple images for each task. In this case, we're just going to use one in all of them. And then we're going to specifically request 2 CPUs and 2 gigabytes of memory. But as we do more complex tasks, we can add in different compute resources here, including GPUs. And I totally did not mention that Union Serverless also has A100s on it right now too. So if you're looking for some good resources to use to train more complex ML models, you can check out using that. So you would just say, you can go look at the documentation, but you would say like GPU equal 1, and then you can put in a special accelerator request for specific types of GPUs. Like someone had mentioned they ran something on a T4. You can also run something on like an A100. So then here's our actual download dataset function. So again, you're just putting this task decorator above a function, and then it's strongly typed. So we're going to be expecting a data frame to be output from this. We're going to download the iris dataset. You might be familiar with this. It's kind of like the hello world of machine learning. We're going to create a data frame out of that dataset. So it comes down kind of as a dictionary, I believe. And then we're going to make a data frame out of it. And then we're going to add the target to it. And then we're going to return a data frame that contains all the features and the targets. And we'll actually see what this looks like. If you haven't seen what it looks like before, we'll see it when we run this task, because we get to kind of explore it a little bit. And then our next one is going to be process the data set. So you can see I hit enable deck, enable deck is equal to true. That's going to allow us to embed those really cool visualizations. So again, don't worry if you don't have this yet, but I will just show what that looks like. So in process data set, we have this little button now called Flyte deck. And then you can actually change the order of these tabs. But here I have this metrics that gives us a pair plot of what all of our features will look like between each target in our data set. So it's a really cool way to kind of understand your data set. And I like doing something like this. If I have a process data set tab, I have this or a separate task that gives me some sort of validation of what my data looks like, because there's been times where I swore I loaded data in right the first time, and then I definitely wasn't. So I always love having some sort of little visual validation, even if it's just numbers. It doesn't have to be a cool visual like this, of just telling me what the data set looks like. And then so in here, we're taking a data frame. We're going to return 2 data frames because we're going to do train test split here as well. So we're going to create a training data frame and a test data frame. We're going to use train test split, which is a built-in function of scikit-learn. We can pass in that data frame. We're going to say the test size is going to be 20%. So 80% of the data we're going to use for training, 20% we're going to hold off so we can look at how our train model now works on that data that it hasn't seen before. Random state is just going to kind of shuffle it, but in a way where we could provide the seed back and see how it was shuffled. And then stratify means that we're going to try to get an equal amount of data for each task in our training data set here. So that, if you just split it randomly, potentially it could be skewed heavily towards one specific class. And we don't want that to happen. So we can just use this stratify part. Then we're going to create that pair plot that I just showed you the visual of. It's going to change the hue on the target and then show us kind of how all those metrics compare to each other, or all the features compare to each other. And then we're going to add that to the deck under the tab called metrics. And we're going to use that convert fig to HTML to save that pair plot image in there. We return the train test split. And then we're going to train our model. Again, defining what images it is. To train our model, we're going to go ahead and up our resources a little bit here. This is a pretty lightweight model, so we don't need anything crazy here, but we're just going to go ahead and say CPU equal to 3 and give it 3 gigabytes of memory. But again, if you're using something like a deep learning model, this is where you would probably define like a GPU and maybe much more higher memory depending on the data set and the model that you're training. So here's our train model function. It's expecting a data set, which is a data frame, and then expecting a number of neighbors, which is just an integer. So this is a hyperparameter that we can tune to adjust how our model learns. So we talked about, if you're here at the beginning, kind of how the k-nearest neighbors looks at the closest number of neighbors and then makes a decision based on that. You could tune this higher or lower, and it's going to be looking at more neighbors or a lower amount of neighbors. And then we're using that train test split. We're going to define our k-nearest classifier model from scikit-learn, and then we're just going to return the train model. We call this model.fit. We pass in that X training data set and the features of the training data set, and it's going to learn those patterns from it, and then we can make predictions with that. Then here we're going to evaluate the model on the test data set, that 20% that we held off in that pre-processed task. Again, same container image. We're enabling deck again because we want to embed a visualization here. And then we're going to request just 2 CPUs, 2 GB of memory. We have this evaluate dataset function, taking in the actual model itself and the test dataset, and then it's going to be returning the model here as well. And let's see, we're basically just running the predictions, running the model on predictions, or to get predictions on the test dataset. And then we're creating a confusion matrix, which again, we'll see here in a second, but it's a way of kind of showing how your model did on each of those classifications in a visual way. We're also going to run something called classification report from scikit-learn that gives you a whole bunch of built-in statistics like accuracy and F1 score on how your model performed. And then again, those will go into the Flyte deck. And then we're going to upload a model to Hugging Face Hub. So this is where you need that Hugging Face token. Again, I have this little thing in here. So if you did want to run this locally, you could, and you could have a .env or a local token saved. So we're going to say get the Hugging Face token. But if it's none, then we're going to go get it from our union secrets. Oh, and I forgot to say, we passed that in specifically here. We said secret requests. We're expecting to get Hugging Face token from our union secrets that we saved. And then I'll say it'll print which one it's using. And then here we're calling the Hugging Face API, and we're going to create a repo with that name that we pass in. And then we are also passing in the Hugging Face token to authenticate it. And then we're setting exists okay, or exists okay to true. So if it already exists, it's not going to create a new one. But if you are running this for the first time or you change the name, it's going to create a repo with that name if it doesn't already exist. Then we're going to save our machine learning model. So again, if you run this locally, you'll have that saved pickle model locally too. But here we're also going to save it in Flyte or Union, and then we're also going to upload the model to the Hugging Face repository. So we're saying upload file, model name, which is a variable we pass in later too, which is that model.pickle, the repo name that we define again when we run it. There's a commit message here. It just says upload model. You could change this as a variable as well if you wanted to. Repo type is none. There are specific ones you can set in Hugging Face, like dataset. None is just going to be the default one where it can save files like models to. And then we're going to have this one last task here that is just going to really take in any other data that we pass it and then run them as predictions on our model. So it's another cool way to kind of test our model, maybe before we actually were to deploy it somewhere. Also, you could use this in a different workflow or just as a task as is, and use it as batch predictions inside of Union or on Flyte. So you already have this compute there. A lot of things, in the industry, you don't need real time. So it's actually perfectly fine to run them as basically batch predictions, and you're okay like getting that data, in a few seconds or a minute or whatever, versus like real time. You can actually use this to kind of have deployed models in your company as well, as long as that deployment here isn't maybe like real-time inference back like a chatbot, but maybe you want to process hundreds or thousands of documents in an LLM. You could have that as a task, pass all those documents in, and then get the return results. So I just want to call that out too. You can actually use this as a kind of hosting models, depending on what you're looking for. All right, and then we're putting it all together in this workflow. We have a workflow called main. We're expecting the repo name, which is the repo and Hugging Face is going to create, the model name, which in our case, we're just going to call it model.pickle, which is a string, neighbors. So we could tune these hyperparameters and adjust how our model learns from the data. And then it's going to take in a little list of floats. So this is by default, it's just going to be this, but this is going to allow us to, again, have that extra little prediction task and pass in data and see how it behaves that maybe we think is out of the realm of the training data set. And then this is the order we're going to call those things in, just kind of how we define them there. But it could be in any order, and you could change the flow of data and tasks here. We have download data set, process data, train model, evaluate model, model predict, and then upload that model. So you should run this code cell if you hadn't already. Now I have that workflow.py, and I'm going to scroll down and run this over here. Again, if you have a Hugging Face account that you created, type in your username that you made. So again, mine is Sage Codes, and then a repo name where you want to save this model to. So in this case, mine's just called ML Repo. It's one that I already have existing, but if you could have a new name here, it's fine if it doesn't already exist, and it'll create it for you. And then let's hit run. And if you didn't run this before, like I had mentioned, you could. It might take a minute or two to build your container image. Again, mine says skip building. And then I'm going to hit this serverless link here. And we can see it's kicking off. It's running download dataset. You can watch this in the node one, the time view. I kind of like this graph view a lot of the time. So you can see, there's this start, and then it's downloading a dataset. It's going to process that dataset. Once that dataset's processed, we're going to train a model. We're also going to evaluate the model, and then we're going to upload that model to Hugging Face. And then we have that model predict task as well if we want to pass in new data to see how it behaves. Someone asks, is container image already built before the first task? So it does need to be built before the first task. So again, if you just ran this for the first time, it probably showed like, image not found or something like that building, and it would show up in that system section in Union, and it would build a new container image there. And it's building that based on that image spec packages that we passed in. And you can actually pass in more stuff here too than just Python packages. You can use things like apt-get and a whole bunch of other stuff to really define your image. And if it doesn't already exist, then it's going to build it first and then kick off the build. So if you just ran that for the first time, you might be a minute or two behind mine right now because it's building an image and then it's going to run all the tasks. So now this is still running, but let's go ahead and click on these. So I'm going to hit download data. Again, we can explore what went on here. We can see the input was nothing because it's just downloading predefined data set. But our output is this URI for where the data set now lives in here, and the format's a Parquet. Something I didn't mention too, so built into all the Flyte tasks, all the data gets serialized and deserialized between containers here. And it's really easy to kind of forget about with Flyte or Union because it just kind of does a really good job most of the time of already doing that. Like we passed out a data frame from this and we didn't have to think about it. It just knew which file to save it in or which format to save it in to pass to the next task. But there are stuff like you can build custom data classes for this as well, which is cool. Let's click on this next one, which is process data set. Again, you can see now there's 2 output files because we outputted 2 data frames. But let's click on this Flyte deck. And again, we have some default things that are in Flyte deck, and then our metrics tab that we created, which contains this pair plot. And we could actually use this to visualize and like understand what our data looks like in all these different 2-dimensional visualizations right now. So basically, this is plotted by each feature by the other feature in a 2D plot. So you can see that like this is what sepal length and sepal width looks like. So one really cool thing about this for like classification algorithms is looking at these bell curves and looking at how these are clustered. You can kind of get maybe a hunch about which features are most important to your machine learning model. So looking at these, like which ones do you think are probably the most important for making predictions? Often, like it does depend on your data and how many features you have, but for a simple data set like this, we can see that, for these classes, there's a lot less overlapping data on the petal length and petal width. Those are probably going to be the most important features for a model to classify correctly which features belong to a specific class, which is cool. Let's exit out of this, go to train model. And we see that our input was the data set, our output was the model. We didn't save any visualizations here, but if you're using something like a deep learning model and you want to save, your validation loss, et cetera, you could actually have that as a visual here as well. Let's look at evaluate model. Again, we have a Flyte deck for this one. So we have a confusion matrix. In this case, this is 100% right for each data that we saved to test on. It predicted the right class they're in. So confusion matrix kind of shows you the real class it belonged to, plotted by what it was predicted. But actually, all these were predicted correctly. We can actually see our precision and recall score and everything like that is actually 100%. With our, I think it was k-nearest neighbors of 3. Oh, that would be one thing to look at here actually is we have the input neighbor of 3. So if we reran this task or workflow, that's now going to be a parameter that we can change in the UI or from our call from our command line when we run it as well. Then we have our upload a model to Hugging Face, and says, model uploaded Hugging Face, ML repo, and it's a model.pickle. And if I go to my Hugging Face account, I go back to look at my repos, I have this ML repo. The reason why mine still says it was only updated 3 hours ago and not just now is if the model's exactly the same, it won't upload. It'll actually say, all the files are the same. We're not going to upload it again. It doesn't just look at the name. It actually looks at the model file. So if I were to change this k-nearest neighbor parameter to 6 or something like that and train a new model, rerun that workflow, then it would upload that newest version to it. So that's why mine doesn't say a minute ago, but yours should say, uploaded a minute or 5 minutes ago. And then we have this model predict. So here we passed in these parameters as a list. So again, these are the petal length, petal width, sepal length, sepal width. Sepal is kind of like an underbelly petal in a flower. And if we want to, we could actually rerun this whole task with new data in. So I definitely recommend it right now, actually, if you want to see kind of how the model behaves. You can add multiple lists here, by the way. So it doesn't have to be just limited to one prediction at a time. So we could take this, and what do you think would be some insane numbers that the model shouldn't really handle? Probably the distribution of the iris data set is something like, 1 to 3 or something like that. Probably what would happen if we put like 1,000,000 or 1,000 in these features. Anyone have any idea of what's going to happen? And then maybe this other one, let's put negative numbers. And maybe a 0. Maybe 0 shouldn't exist. Any idea what will happen here? I'm going to hit relaunch. It's going to run this task again. So again, we have this model saved now, and you can actually use it to run inference in, which is very neat. It's going to take a few seconds to spin up here. Running. And we can see our input and then our outputs. And I actually do have a Flyte deck enabled here as well, which allows us to kind of more easily see, I guess, you could format this way better, by the way. But you could, see all the inputs here and then the outputs that were predicted back in a list as well. And so we put some pretty crazy numbers in. That's because we don't have any data validation, which we maybe should have in our pipeline here. And something I recommend for building more robust pipelines, right? Like if we're expecting nothing to be negative, we should have that defined somewhere. And maybe we know like any flower size shouldn't be over a certain amount of inches or centimeters. Then maybe we should have that defined too. And the way it works is, for the k-nearest neighbor, it's still just looking at the closest neighbors, even if it's way out of spectrum. It doesn't matter because we didn't define that. So it could be way off the charts, and it's still going to be looking at the closest neighbors. And that's why we're still getting stuff returned, which is pretty fun to look at. And using that kind of predict task in here makes it easy to kind of maybe do another little quick spot check on your model without having to rerun a whole pipeline. So I kind of like having something like that there if it's a lightweight model for sure. I go back to my dashboard, go back to my whole pipeline here. So we have a little bit more we're going to go through back to the notebook that's just downloading the model from the model hub. There might be some questions I missed, but also want to ask again if there's any other questions. And also, what do you think? What do you think so far? We went through, we built a really, like the model, the pipeline itself might not look super complex, but we use kind of state of the art tools here that you built a reliable pipeline with versioning and caching. A lot of really cool, not tools, but I'm blanking on the word. A lot of cool features, a lot of really cool features that you'd actually be using to build models in the real world at scale in production. And what do you think about it? Especially if this is your first time doing something like this, like what do you think? If you've used other tools or built pipelines in the past, how does this compare? What are your thoughts on this? I'm gonna get a drink of water. Well, hopefully you all are typing in the chat. And we can go back to the notebook. I'll quickly run through. There's just like one more code cell, and then I'll stick around and answer any other questions that I didn't get to. So if we want to download that model that now exists on Hugging Face, maybe we want to download it onto an edge device or somewhere else where we actually want to deploy it. We can go ahead and run this next code cell. The only thing you'll want to change here is, oh, I totally forgot. We do need our token again here to download it. My bad. So if you have your token still saved, grab that. If not, make another one. I think I already exited out of my token again. So we need an authorization token to be able to download our model. And you could actually just create one that could just read access because you don't have to write to it. I'll just do both again. But so maybe you want to make a new token on an edge device, and all it can do is download models. Let's say workshop 2, create token, copy my token again, back to the notebook. So put your token right here. And now put in your exact username again, Sage Codes in my case, and then I had the ML repo. And now we'll run this. And it's going to download the model pickle file that was saved in our hub. We can see it downloaded. We can look at the model object. See, it's a k-nearest neighbor classifier with nearest neighbor number is 3. And then we can interact with our model, run predictions again locally. We can see class return 2 and class return 0. You can mess around with these numbers, but we went from training a whole model with this pipeline, seeing visualizations. This is all version now. We can relaunch that pipeline. We could train a new version with, again, let's say k nearest neighbors to 6, and we could change our prediction data if we wanted to. You could upload this to a different repo if you wanted to, all just kind of in this interface now, which is neat. So let's launch this again. And now we're going to run our pipeline again, but with new hyperparameters for our model. And what's cool is we had caching enabled for our data set. So when it runs this time, it's not going to have to download it again. It says caching was, oops, I think I had it enabled. I'll have to double check that. But yeah, so caching should be enabled here, and then it doesn't have to download the data set again. And even though I don't think it did because it ran so fast, so I'm not sure what that is in UI. I'll have to take a quick look at that. But now we're rerunning our whole pipeline again with a new model with different hyperparameters. Again, we could look at the input. We can see that k nearest neighbors is 6 now. And it's going to run through and upload that model to the Hugging Face Hub, and then I could pull it down and interact with it again. So what do you think? You built a whole pipeline thing so far. Again, I see some people. I'm going to catch up with questions now. There's a lot that we didn't cover. We're just kind of scratching the surface of, building pipelines and using Flyte. There's a lot of really great features. So check out all the documentation. Also, I'm doing another event next week, and it's going to be building a scalable pipeline for large language models. So we're actually going to fine tune a BERT model, and it's going to be a little bit more of a complex pipeline and use a GPU. So if you're interested in doing, another workshop on this, but with different types of models and different types of workflows, join me at the next workshop, which is August 29th. I think that's Thursday. And it should be a lot of fun as well. But yeah, I'm going to stick around for questions. So I see there's still some that I'm missing in the chat. Let's see. So someone said they built it. I'm scrolling up a little bit, and then I'm going to scroll back down. So if you have any other questions or things you want to point out, put them in the chat as well. Someone asked, why is there no Flyte deck for a train model? So if we go back to our code, for the ones that we use the Flyte deck, we can see that we specifically tell it to do that inside of the task here with enable deck is equal to true. And then we've only done that for things that we're specifically passing in more data to. If you do just hit, and by more data, I mean, like we said, we want this like a new metric tab, or we want to save this to the Flyte deck. But if you just enable it for something without doing that, you'll get these default metrics. So you can just enable it if you want to look at like the source code, copyright here, all the dependencies, the input outputs logged. This is for the processing data. So we can see the input was this data frame. It gave us 2 data frames, but also we appended this metrics tab to it. So you can enable it for anyone that you want. You just have to declare it in your pipeline code there. So instead, this is by far the best pipeline workshop for mid beginners like me. The UI is so cool. Awesome. I'm glad to hear you comment on the UI too, because I mean, I use it all the time. So it's easy to get used to it. So it's really fun to kind of hear fresh perspectives of what people think. So I love hearing that you think the UI is awesome. Very cool. And again, join the Slack channel. And if you have any questions or feedback, let us know. Like if there's something you don't like in the UI, let us know in the Slack channel. But it's also great to hear what you do love. That's always really great to hear as well. Someone said the workflow is so much streamlined for machine learning. There are very similar products, for instance, Fabric. Can you go through some of the features that differentiate from it? I haven't used Fabric yet, actually, so I'm not quite sure how to differentiate from it. But I'd love to hear your perspective on some things here too. So one of the things like talking with people that maybe it's Fabric. I've talked with other people building stuff on um, some of the other cloud kind of infrastructure piece, and a big part of it is some of the features. Like I was talking to someone who used a cloud orchestration tool the other day, and then I mentioned how you can run these workflows locally. That was something that really like kind of blew their mind, because I think debugging in a cloud environment isn't always the best. Although I will say, and it depends on the cloud environment, sometimes you have to dig around for error codes and stuff like that. We didn't generate any error codes here. Let me bring up something real quick. So I think I have a workflow that failed the other day. One thing that also a friend who works a lot in some other cloud environments mentioned they love was the logging. Like you don't have to go into all the logs to find error codes and stuff when you are debugging. You have this like show error function right there, which I don't know, stuff that seemed really small, but makes a big impact when you're kind of quickly iterating. And then yeah, the built-in features like automatically versioning, um, task level resource management, caching in the pipeline, like we saw today, built-in type safety too. Again, not being familiar with all the other ones, this is something too that some people really like, where you're kind of it's a convention in Flyte that you're kind of forcing people to implement best practices in. So again, kind of seems somewhat small, but can save a lot of time in debugging. Yeah, if you've used another one, I'd love to hear maybe some I don't know, more specific questions, I guess, or comparisons you might have in your head already. Like, are there features maybe that we talked about here that like you haven't seen in the other ones that you're looking at? And also, so I still see quite a few people hanging around. Happy to hang around and I don't know, go through any of the other things here. We are over time, so I probably will drop off pretty soon. But if there's any other questions, let me know. And again, if you just joined in later too, but you want to follow along, um, all you really need to do probably is hit the sign up link to try the beta version of serverless out. Someone said very cool and efficient. Awesome. I'm glad you liked it. And I'd love to, see if you build more projects on it. Does anyone have any project ideas that they're excited to build? Or maybe you saw something here today that you're excited to use? Someone said being able to run it locally is, I believe, the coolest feature. It is really cool. And yeah, sometimes it blows my mind that you can't do that with other tools. Oh, one other thing too that I didn't mention, and I don't know how to compare to the specific tools you mentioned. So here we're running all of our code in like one .py file here, but you can actually save these in different like Python files and modules like you would a well-structured project, and then import them in and create tasks. So it looks like a big Python file today, and it makes it way easier for the workshop to kind of scroll through and explain everything that's happening. But I know that some other orchestration tools too, I think you're kind of more forced to actually write in this format. So if you actually want to have like a like they really try to make it easy to write your Python code kind of how you want, with a couple best practices like the typing and stuff in there, but have a really well structured project. And then really just adding like tasks around it and this declarative infrastructure over kind of hopefully the Python code you would have wanted to write anyway. Awesome. Well, this was a lot of fun. Thank you everyone who came out, and especially everyone who asked questions and followed along. If you do have any questions later, join the Slack channel. Again, always say hello in the introduction channel as well. I think you're saying is the train test. Sorry, let me parse what you're saying. Or someone's asking a question about besides cache, do you write the downloaded train test data for later reference? Yeah, so everything's versioned in here that you can access again. And for serverless, I forget if there's an official policy of retention time, but yeah, so like you can come back to this and then pull. Maybe I'll add this to the notebook next time too, of like pulling specific, like pulling down artifacts basically. So all these tasks, and each time we run a version, so we have a new workflow version, that data is basically stored per task here as an artifact. So I think the answer is yes, but specifically on serverless here, there might be some stipulations for the official retention time. I forget what that is. But so most people use Flyte or use Union Bring Your Own Compute, where you're connecting to your own compute cluster, and you can have that as persistent storage. And then sometimes there, you also might want to figure out what what that retention policy is for you as a company too. If you have really big models and really big data sets, you might not always need every single version too. So something to think about, I guess, when you implement it. I'm going to go ahead. People are still here. I know people are dropping off. I'll run a workflow one more time while people are still hanging out. Oops, I want to get the whole workflow. Oh, one quick thing too. You could check out this visual workflow builder. So we have those tasks we defined. If you like, this isn't a no-code platform. You saw we defined everything in Python SDK, but there is some cool stuff where we have this visual workflow builder. If you want to kind of experiment around and build tasks or build workflows with existing tasks, you can do so by dragging and dropping those tasks we defined and then making a new workflow, which is pretty cool. So we had download data set, and what do we do after that? Process data, right? And then after we process data, we train a model. And then after that, we evaluated the model. And then in this case, we'll just do that. I don't think we need to run the other ones right here. But you can actually kind of create a new DAG here with those existing tasks. Let's see, we had the data set. We goes into pre-processed data. It's a training data set. And then this one goes to evaluate. Oops. Evaluate. Then we want to pass in a model to evaluate the model. And workflow version. I'll just call this workshop. And we can create a workflow. So version 1. Oops, I should have gave that probably a better name. But now I can go look at this workflow that I created with the visual workflow builder. And then launch the workflow. Oops. So kind of a cool little visual way of building new workflows from existing tasks. Someone asked, which framework do you mostly use, PyTorch or TensorFlow? Oops, I might have done something. I wasn't really paying attention. I might have done this poorly, but you get the idea. There's a visual workflow builder. You can take existing tasks. Actually, I think I took the wrong download data task. I'm pretty sure that's what I did there. Someone asked which, if I like PyTorch or TensorFlow. PyTorch right now, there's so many cool developments just always happening with it. It seems to be the most up to date, or like new features coming out. TensorFlow, I used to use TensorFlow a lot in the past though, and they have a lot of really cool things around like specifically deployment and optimizing models, like TensorFlow Lite, and I believe you can convert probably a PyTorch model to that format as well. But yeah, right now I think I mostly use PyTorch. But if you have a use case for TensorFlow, I'm not bashing it or anything like that. Do you have one that you like? Are you looking are you just getting started out? I think also PyTorch. Most people use TensorFlow with Keras, which is like another framework that does a pretty high level abstraction of stuff, and it makes it maybe easy to do, but you kind of miss out a little bit on some of the stuff happening behind the scenes, which isn't always a bad thing. But I think that the way PyTorch does it, it it kind of allows you to fine tune more what's going on behind the scenes, but also you're going to understand a little bit more probably what's going on. And also, if you're doing things with like large language models or a lot of the new stuff coming out, PyTorch is usually the framework that people are using for that. And then also, like I was saying, deployment's gotten more mature. They have a new, I forget what it's called, but like a new mobile kind of PyTorch for deployment and a couple of other things going on. And then also a lot of people might convert that model type anyway, do a different model type pretty often. There's one called Onyx that's used for exporting kind of models in a different production format. We just ran a pipeline again. It's that easy to rerun pipelines here. Cool. Any other questions? Otherwise, I think I will wrap up the stream. Again, this is really fun though. And you could try, like I totally suggest trying to build a PyTorch pipeline here. Actually, next month, I don't have it posted yet. Like I posted the LLM workshop. Next month, I will be doing a workshop using PyTorch for computer vision. So we'll be implementing some sort of computer vision algorithm and building a computer vision pipeline in it. There's a couple different ones I'm working on. So we'll see which one I'm going to do a workshop on first. I think I want to do it on object detection, though, not just classification, because I think object detection is kind of more exciting. And you get to see how to create data for object detection, train a model on it, and then like bring in your own video and run a model on that video, and get a really cool result of like, tracking, or well, we won't implement tracking, but where you're detecting objects in every frame, you get a really cool visualization from it. And a lot of the times people start with classification, which is great and has a lot of cool use cases, but I think object detection is more fun and there's more use cases you can do with it. They said your senior suggests to learn PyTorch, as most research papers are written in that. Yeah, definitely. I think most of the new stuff coming out is in PyTorch, and if you're not like familiar with one right now, go with PyTorch, and I don't think you'll regret it. All right, I'm gonna go ahead and wrap this up then. Thank you again, everyone, for coming out, and hopefully I will talk to some of you all later, whether that's in Slack or on LinkedIn or at another workshop. Have a good one. And again, if you have feedback or questions, let us know either in like comments where you're watching or in the Slack channel.